Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter written in Swift. We've done a fair bit of work. We got the amazing maze working last time, so that was cool. And we're backfilling some places we didn't make it as fancy as we could or should. There's a lot of variations in basics, and we'll add the ones we need for the little programs we want to run. And in particular, this case, it's the dimension statement and there are at least some basics out there that want to do these with expressions, so values that are computed at runtime. In the case of the Amazing Maze, it's what's the width and height of the thing, and they want to get that from you and then use an array that big. All right, we got halfway in last time. Oh, hey Rick, good to see you here. Let's see. So we had these failing tests, and I think the issue is we're saying, oh, really, we're expecting we should calculate the dimension size. It's not the expression; it's the expression plus one because the array has a zero slot as well as the number they give. But I think what that's telling me is we're saving the wrong thing. I think rather than saving 6 and computing that size, I think we should just save 5 and let the runtime side, the interpreter side, worry about that. It's the one that needs to know the array size so it can compute the indexes and all that stuff when you access it. So let's have it tell the real thing. So let's find our dimension statement in the parser. Okay, so we're going to calculate the expression, and then I think we're just going to append the expression. Okay, rather than plus oneing it. Okay, so what I want to do is make the parser tests run. Okay, and that was a diff. We'll take this off here too. Okay, so I'm now saying dimension statement should only provide the actual answer. And several of these will fail because they're computing n plus 1. I think we have one that computes it. One that expects the plus. Okay, so let's go to the test. It failed dimension A number 5 instead of dimension A6. Okay, so that's this. Same thing here. And this should be 3, 4, 5. I mean, I'm liking the way this looks to verify it. And yeah, because I know I definitely messed these up while we were developing these tests. So could that have told me? Well, yeah, I probably should have too. And here's our dimension 2 plus 3. It's just going to be, well, this one is not going to be a number. It's going to be number 2 and number 3. All of that in an op2. Okay, so 2 times 3 and type is number. Okay, so I think these should all pass. Okay, but when I run the full set, I'm imagining there's going to be something wrong in the interpreter. Okay, I'd be kind of disappointed if there weren't. All right. So this is saying dimension statement takes into account the plus 1 and allocates those numbers. Same thing here. In this case, the assertion is right. It's our code that's now wrong. Okay. And I think, let's see, where's dodim? Yeah. Okay. So dimension values, I think these are really dimension sizes is kind of what they're going to be. Okay. Um, and these numbers that we're pulling from the dimensions, they they just really need their plus ones. Okay, so we'll take whatever number we got, add one to it, and then we multiply them all together to get the full size. All right, and I think this should work. I didn't realize this was going to take, 5 minutes. Oh, well, there we go. Maybe it's not 5 minutes. Okay. Array without dim defaults to size 10. And this defaulted to 12. Hmm. Let's see. So there are several places that call do dim. Let's find them. Okay. Yeah. So this one, do dim, we should make it a 10 now, and I think the same thing here. Yeah. Okay. And I don't know. I feel like I should pull that into a constant. Um, Let default array size equal 10. And I have to say interpreter. L. I guess I can deal with that up here. We don't need it static, and we'll just make it a float. Count 11. Huh. Okay, what's the other failures? Without dim defaults to size 10. Assignment, array access. Oh, because it's set to 12 for whatever reason. Well, somewhere we're adding the 10 before we expected to, I guess. Do dim dimensions type. Okay. Let's. I hate to be paranoid. I just want to make sure we're running clean. Ugh, okay. Well, I don't need this then anymore, probably. Okay, good. And that was all tests. Okay, so make the parser put in the actual from the code, let the interpreter adjust the value. Okay. Dim should allow expressions and dimensions. Okay. That, I believe we've finished that. Okay. Let's see. REPL should scroll to bottom. We kind of gave up on that one. I don't know what's going on there, but okay. RAND should be repeatable. Yeah. So, again, this is one of those things that varies. Sorry, let me clean something up here. All right, I've lost my documents. Okay. Okay, let's push these over to another desktop. Okay. It's the original. There's Commodore 64. Okay. So I think I want to, the original, I don't know if they described it. RAND produces a number between 0 and 1. The argument has no significance. Okay. That's the original BASIC. The 8K BASIC, circa 1978, I think, 76, is a little different. It says random number 0 generates the same number always. I think I don't care for that. I don't find that very useful, but okay. But random X with the same X always generates the same sequence of numbers. So we'll make a test. But that part I want to enforce. What I want to do is something kind of in the middle, right, with whatever justification that has. Okay, let's find rand on the Commodore 64. They make it pretty complicated. Okay, 0 to 1. They don't, I mean, it's like it doesn't really hit 1, so they should say that. If it's positive, it's a pseudo-random sequence starting from the given seed. Different numbers result in different seeds. Okay. 0 generates a number directly from the clock, so it's sort of totally random. And then negative reseeds on each function call. So I think what I want to do is 0, let it generate a random number off a seed, whatever clock or whatever, some random thing. And then X, we want to make sure it does. Now, we did some of this in one of our earlier projects, and I don't know if I can remember which one, so forgive me. I think it's blocked. We did a simulator for the OSI machine, and maybe that's basically environment, random seed. Yeah, so we defaulted to 0, and if it's 0, oh, well, okay, this one's like OSI, it just returns some random number. But this one, it checks if the seed is different and generates a new float, puts in a new seed, and then generates a new value from this. And I don't remember DRAND48. Is that really 0 to 1? DRAND48 double. Okay. Let's find documentation on that. DRAND SRAND Mac. Okay, DRAND48. All right, produces a double. SRAND, give it a seed. Okay. Okay, good. So DRAND48 does produce things in the range 0 to not quite 1, and that fits us. Okay, so we want to get similar behavior over here. I'd like to just, if it's 0, randomly seed it, and then if it's not 0, reseed it. Okay, and generate that sequence. Okay, so let's where can we do this? I guess it's interpreter. All right, so let's find rand. How about over here? Okay, so right now we just do float.random. Okay, but that's not going to be good enough. All right, so identical sequences. Okay, so this is a little right. So what I want to do is 1.10. I want to call I guess I got to do it for each. If check program results is not going to help me. Okay, so let's do for each. Okay, so what are we going to do? Well, we're going to catch this stuff. I'll put that drop last. Well, I think we can extract that. Let's pass in an argument. Okay, so we'll make a program that does that, and then this much I would like to extract. Oh, cool. Oh, well, that's not going to work, is it? Okay. Because if I start every program over with the same seed, it's going to get the same value. So I don't want to do 1 to 10. I think what I got to do is do to my code. Okay, so let's write a basic program. 10. Well, okay, for I equals 1 to 10. Print random of 42. Next I. Let's do it this way. We'll print, and then let's do this. 1 to 10. Put my caps on. Print random of 17. Okay. All right, so I'm going to generate a sequence of 10 numbers based on 42, and then 10 numbers based on 17, and then back to 42 and back to 17. All right. And let's interpret program. Okay. And then let's take outputter dot output dot split new line. Okay. Let's save that. So line sub 0 should equal to line sub 2. And line sub 1 should equal to line sub 3. Sorry. Find rand. Okay. Seeds force identical inputs. Okay, so build an output object. We've got a program. We'll do that. Have I messed up my braces or something? Looks like it. Okay. Oh, have I totally hosed things? Apparently. No, we're good. Okay. Find rand. All right. See if I believe this. Okay, so we split the lines. We should get a bunch of numbers, 0 to 1. Yeah, let's see what we get. Two failures. Okay, these two lines don't equal. 0.749 is not equal to 0.41. And 0.702 is not equal to 8.89. Okay, I think we can work with that. All right, now the function. I'm going to extract this into its own thing and make a little helper function. Random, and according to our thing, it's a it should be number to number. Rand, number to number. Okay. Let's take all this. I think that's float. Okay, so that should give us a random number generator identical to the one we have. Let's make sure I can call it here. Random. I might have to. He might not like that. Yeah, I think interesting. I don't think it built. Random. Yeah, I need to make it a static function, I guess. Okay. Hopefully that'll work. It'll still fail the same way, or well, they may be different numbers. Yeah, they are. Okay. Right, and let's make a static last seed equals 0. Okay, and the behavior we want is, it's more like, whoops. It's more like this other package, the blocked one. Environment. So we're going to return float of drand48. All right, this should still fail. The first random test should pass. Okay, and again, just a totally random sequence. All right, but now we're going to do the seed bit. All right, this. So it has a default seed that's, I think, based on the system clock or something. So that's tolerable to me. All right, so this, oops, interpreter. This is last seed. Now, maybe a type issue. If number, well, let's call it seed. Can srand48 take a float? No. Okay, we'll do this. Okay. Yeah. All right. So we've dealt with that. And then, I guess this one proves if you run it twice with 0, you get different numbers. Can we make it do that? Let's just well, maybe it's a new test. Random numbers are in proper range. I would say that's what that one's doing. And then let's make one default seed 0 starts different each time. And I'm assuming 100 would be enough to prove it. After a while, you should be able to sorry, last value of float equals 0. Okay. And then we want to do this stuff. Assert not equal last value and value. Okay. Cannot convert value of type null throws to void. To expected type closed argument element throws to void, aka int throws to void. Oh yeah, I gotta ignore my happy. Okay, so I'm gonna run 100 times, and make sure that it starts out with a different value each time. And since each one's running its own interpreter, then we should be okay. And this should already pass. I mean, I think we saw it up here from the values we were seeing in the list. And really, I don't even know if we need 100 times, because what we're watching against is this blocked implementation, which imitated the OSI that just returned the same value every time if you did 0. Okay, we're saying no, 0 should just be a random sequence with a random seed, okay, that we didn't control. Okay, I believe we are done with that one. Range should be repeatable. Okay. I should reword these when I first create them. Dim allows expressions in dimension. Maybe range is repeatable when seed is non-zero. Okay. All right. Cool. All right. I mean, I'm not going to tackle REPL today. Doesn't support the tab function. Well, right now, okay. The deal is, to do tabs, right, you kind of have to know what column you're in, because, well, you're gonna tab forward to column, some new column. And the same thing with the tab function. Tab, let's see, we'll find that here, I think. The older OSI one had it too. There's tab. Move the cursor to position depending on the numeric argument. So starting on the leftmost position of the current line. Can only be used with a print statement. Yeah, okay. I don't think we care. Well, do we care? I don't know that we care. We certainly want to support it in the print statement, but I'm not sure if we care what you do if you use it in a computation statement of some sort. Maybe it just returns empty string or 5 spaces, or who knows. All right. So let's phrase this positively. Support the tab function. But I think it might make sense to deal with the print stuff first. So this is stuff that we knew print did, and we just put a primitive print out there. Okay. Print with semicolon. Numbers have a space before and after, no space between strings. I think we kind of do that. I mean, it's up to numbers to print themselves, so it's not the semicolon. Okay. And so I'd say we did that the other day. Yesterday. That other day. Okay. Okay, I see. Okay, print with semicolon. Numbers have a space before and after, no space between strings. Okay. This one we haven't done. And I think the problem is that we need to keep, I mean, on the Commodore 64, right, they were just blasting stuff onto the screen starting in a position. You didn't have to worry. You just needed to know which line it was on, and then you just overwrote that column. In this, the way we are, we don't really have that option. We're producing the string results and not restricting ourselves to a particular screen size. So I think our output object is going to need to know the current column, and it doesn't know that yet. All right. So I think, what do we have to ask? Well, I think if the outputter could tell us the current column, we can figure out the rest. Or we could say, I'll just tell you tab, and you figure it out. Boy, my lucky day. Okay, so let's make the assumption that if the outputter told us the current column, we could figure out which column to use. Okay. Alrighty. So let's look at our outputter. Output. We haven't seen that for a while. Output. Where are you? Oh, that's in REPL still. I think it's time it got its own class. Oh, wait a minute. What have I got going on here? Did we not check in? All right. And output. Seems like several of these could. It's in the REPL. All right, let's pull it out. Let me get rid of this combined stuff. All right, let's make sure that works. All right. And then do we have any output tests in the REPL? Nope. Let's make some. I'm going to just make a regular file. No, I better take the framework. Is this? Let's try this one. Okay. Well, let's backfill. We really just have append. Let's make sure appending appends to the file, to the output. And I don't think there's anything to say really. Alrighty. So I think what we want to do is we want to get the current column. I guess we want to know how many characters have been printed on this line. Okay, so let's do that. Test output tracks column. Okay. All right, if we start out here, I'm going to say that output dot column equals 0. I don't know if that's the best name, but that's what we got. Okay. All right, this should fail. Okay. Now, I'm kind of, I'm kind of known for inventing a range act assert as sort of how do you write tests, but in this case, I think it's going to be easier if we just don't do it that way. Let's append some stuff. And, well, there are 3 columns to the left. 3 characters to the left, so 3. Okay. And then, so I think in some ways that's the tricky one. I'm going to do the whole mess. Let's put a new line in, and then A, B, C, D, and column should be 4. So column you can think of as the number of the next column you're going to write to, or you can think of it as the number of characters to your left. Yeah, it's a little tricky to go back and forth. It's easy to get off by 1, but if I think of it as characters to the left, then that makes my head work better. Okay, I have to think about it less, I guess. All right, this will fail. Okay, and the reason is what we have to do is we have to go to the last line of text and extract the column from that. And that's a little tricky, I think. Okay, so this string, it kind of depends what we have in the list here, but I don't think there's anything that makes it easy. Well, we kind of can do last where. Let's see what that gives us. Returns the character. I guess last index where predicate character throws bool. Returns a string index. Oh, character. Okay, so last index of that. Okay. Let no, I really want the substring. Okay, maybe I'm gonna. Is there a substring? From please use string slicing subscript. Yeah, I think I can do output dot. Next. Dot. Well, can I just do that? Okay, let's address our simple case first. If last index equals nil, then we're going to return output dot length count. Okay, so so I'm not going to address the other case yet. Last index equals nil, meaning there is no new line yet. Then we should just count what's there. Okay, output tests. Yeah, so we expected the 1, 2, 3 to pass, but this one to not because, yeah, 42 is our default answer. All right. So if there is no new line, then we're going to take output.lastIndexSub, That's the substring starting at last index. So it's new line plus whatever, and that means it's one too big. So let's take it off. So we're basically taking off the new line character. And so if it was new line ABCD, that's 5 characters. We want to say the index is 4. Cannot convert value subsequence. Oh, dot count. All right. Okay, so I think that's the 3 cases. We could make them unified if we put a new line first, but I think that would kind of mess up. It would mean we had to pull it off somewhere else, and I think that would be just as confusing. But okay, so in our to-dos, print with that. Let's make output no next column to right. Okay, and so we're doing that. Okay, and then I think we want to move on. Okay, print with comma. Okay, we don't support that yet. We have comma already because function calls and subscripts use it, but the parser does not accept it. Let's see if I can find the parser. Okay, and do print, I think it's called. Not door bent, do print. Well, it's something about print statement, okay. All right, yeah, token not column. If it's semicolon, do something, otherwise just treat it as an expression. Well, we need a case for comma, and we also had the notion of a thin space. I think we'll have to introduce this tab space now too. Okay, so I think we're due for a break. So let's take about a 3-minute break, and we'll come back and get these tabs in there. See you then. All right, welcome back. So tabs, let's get the parsing going. So we'll add this case. I don't know. I don't think the word space adds anything there. I guess there's going to be places in the interpreter that look for it. Yep. Okay. And we'll just put some junk in there for now. Okay. And build. I don't know if any tests will care. Okay, good. Parse and parser. Okay, so we need a test that deals with the tab case. Let's find our prints. Print, okay, number. Well, that'd be a good check. Comma at end of print suppresses new line. I don't know if I like these being there. I'm still not sure about that stuff. The thin space in particular, I don't think adds anything. Tab does. Okay, this should fail. Okay. and expected start of expression because it was looking for some sort of expression and got a comma. All right. Okay, so values dot last. Well, we gotta do the same thing as we do here. Okay, so let's do this. If token is tab. Sorry, if token is comma, then append a tab. Okay, and then values dot values dot last not equal thin space, and values dot last not equal tab. Okay. Okay. Now, what else can we check? Well, I guess we just want to know that this is in the list. We sort of proved that, but we'll check it explicitly. Test tab in print, or comma in print. In print yields tab. Close that. Close the statements and that. Missing parameter. Oh. And print's new line is true. Type printable. Oh yeah. We have to wrap that. Expr. And let's format this a little. Okay. Should pass. Okay. Parser supports comma in print. No, that's not what I wanted. Okay. And then I think we just have to deal with the interpreter now. No, we want to start earlier than that. Check print. print with semicolon. Okay. Yeah, let's do the comma one first. All right, if we print 1, 2, well, let's 27.10. And string. Okay. Now we got to decide how we're going to deal with the tabs. I think the C64 was actually the way to go. I think they did 10 space tabs. Let's find print again. Okay. Print. Okay. Yeah, 8 print zones of 10 spaces each. Okay. So what we're expecting then, whoops, is down here. Okay. So I'm not sure about the space in front of the numbers. I don't think we do that, but 1, 2, 3, 4, 5, 6, 7, 8, 9. 10. Am I counting right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So tab it 1, 11, or 0, 10. Okay. 27.125. That's 6 spaces. 1, 2, 3, 4. str. Okay. Yeah, that's what I expect. I think we're going to get some junk in there. Okay, yeah, there's our tabs showing up. We got more precision than I expected. 3, 6, 9. 1, 2, 3. 1, 2, 3. Okay. Yeah. Good. We can work with that. Okay, so tab. Oh. Shoot. Let's see. We gotta see who calls printable. Oh, there's our map. Okay. That's just not going to work, is it? Right. I think we're going to have to map them. I think we're going to have to append them right away, because we don't know the position until we look at the outputter, and if we haven't put the ones that are preceding us on the line, it's not going to work. Okay, so let's change this around a bit. So let's say try values, and then values.for each. Okay, let's treat this as a refactoring for now. So um, let um, printable equal printable sub $0, and then outputter dot append printable. Now we're getting rid of these spaces. This is instead of that. So something's going to be funny. I put it append. Okay, that goes way too. What I think may need to happen is our formatting of numbers may need to take things into account. Basic format. All right, let's see how we do. I think we're going to have answers with no spaces that we wish had spaces. Okay. Print with multiple expressions. X equals 0 is not equal. X equals 0. Okay. Excuse me 1 second. All right, sorry about that. Okay, so yeah, so the difference is we don't have a space in front of our 0 now. And I think we need to. Print 42. Oh, this is interesting. Yeah, this is tough. I think that one may be wrong. At least the Commodore 64 version said numbers always are followed by a space. Positive numbers have a space between them. Actually, I think that's non-negative, but space between them, preceding them. Okay, so I think by that interpretation, a number should have a space before and after it. Okay, and so I think our format, let's find basic format. Okay, I'm going to move this a little closer. Okay. I'm not quite sure the right level for it, but I think we'll just say space. Let's see. Numbers afloat. Okay. Hey. Okay, let's see. I'm getting buried. Okay, so let's see. So I think, how's this doing? This is still failing. Okay, let's take this one off the stack for a minute and just address this other one. Okay, should get. Yeah, if I've got a build failure. Oh, basic format was okay. It's a standalone function. Okay, so that's why it's out there. All right. Try again. And again, we should get one failure. Print with commas. Yeah, that one's not there. Okay, but this one's real. All right. Interpreter. So I think basic format, I think we're going to say, let's say var result equals nothing. Let's make result equals this. And result equal that. Okay. And return result. Again, one failure. One real failure. This one still not getting a space. Okay, so I think we want to say well, I'm going to say this. If number is less than 0, return result plus space. Otherwise, sorry. Otherwise, we return result space plus result plus space. Okay, so if it's less than 0, it just gets a trailing space. If it's more than 0, it gets a leading space. I think that's consistent. I don't think it's tracking if there's a space at the end, but some different tests should fail now. Maybe a number of tests. Maybe more than I want to deal with. Okay. Ugh. Okay. Yeah, okay. Let's try output.trim. Do I have a search window? Really trimming characters in. Ugh. Oh my goodness. Okay, I guess we'll do that. Okay, so this is dot trimming characters in white space and new lines. Does that look right? Value. Let's say that's got to be a value at this point. And there should be one there, so it should be converted. Okay, I think we had a bang before there. So let's just try this one. Okay. Print with commas, we'll work on that. X equals 42. Well, now we're saying we really expect this. Odd as it seems, but it's pretty common. I mean, most of the basics, they kind of tried to do that for you to just to simplify the formatting and stuff. So if you left out values, you just didn't have to specify a bunch of formatting values and deal with it. They just mostly kind of work. I don't like that trailing space, but I'm not sure I know how to fight that well. I think we got most of them. Well, this is the same issue as the other one. Oh no, it's not. Something else. Found nil. Output. Okay. Oh. I did it differently. Okay. Output. That's fine. Print 20. I don't know why that one didn't complain, but let's. Nope, no leading space on this one. So I guess lots of numbers will kind of line up if numbers have the same sizes. I suppose that's what that's accomplishing. Oh, okay, we'll have to go back up to check opposite. Check print with rel op, expected. Yeah, unfortunately, the numbers were expedient to use to check these things.
Hey.
Leading and trailing.
We have a mama and two baby deer.
Oh yeah?
Yeah.
Down
They
in
just
there?
went. She just went that way. But one baby's over here, and it's like just watch the other mama and the other baby go romping that
Go
way.
around that way? Yeah.
Only trailing.
Turkeys and raccoons.
Right on.
Yeah,
Y'all also have wildlife back there.
we do.
That's character. No leading. I did some of these, but not others. Okay. Down here. I don't know. I'm not sure what the deal is there. Okay. Oh, goodness. I'll try this multi-line thing, but I've screwed it up every time. Is it structure?
Sophie, the one fawn is tucked in over there. The one fawn. But a mama and a baby just romping up the hill. So I don't know.
I can't do it that fast. I can do this a lot faster. Sorry about the background noise. Oh. Really? I can't have multi-line? Oh. Um... Huh. This is really weird. Okay, I'll do it this way. I hate it, but I'll do it. Oops. Okay. Okay, I'm gonna mute while this is running. Okay, I'm hoping we'll pass everything now. Good. Okay, so we made numbers print with trailing spaces and with leading spaces if they're non-negative. And that is probably worth noting. Oh, this one we've done. And we're kind of stacking here. Tabs with, well, let's do 11, 21, etc. And I don't know that I want to limit the print zones. I think we'll just let it be. We may have to change that decision at some point, but I think that's okay. All right, excuse me. Okay, now we can get back to our tab test. Let's find X test. Okay, print with commas. Should fail. Okay. Now I think we're in a position to do this, though. Okay, so here, let's find our print stuff again. Printable. Okay. So a tab, well, basically, we want to take the current column I think we basically want to take the current column, add 9, and divide by 10. Is that right? And add 1? Or maybe not. 0, 10, 0, 10, and so on should be our numbers. Okay, so if you tell me 0, and I want to hit the next tab, do I have to add 10? I mean, I want 0 to come back with 10. Okay, and I want 9 to come back with 10. So if I take, yeah, that doesn't sound quite so hard, does it? Okay. Let current column equal output dot column. Okay, and so if we are on 10, we got to go to 20. All right, so I think we just want to take, we want a constant. We'll create the constant here and let columns per tab equal 10, not 2 or 4, apparently. We'll spare that argument from ourselves. Okay, so if columns per tab is 10, let result equal, if we take the current column plus columns per tab And we divide by columns per tab. Okay, so 0 will go to 10, divided by 10 is 1. 9 will go to 19, divided by 10 is 1. 10 plus 10 is 20, divided by this goes to 2. Okay, so I think that's about right. So, well, what's that doing? Result. Well, result times 10 is where we want to be. Maybe I could subtract this off somewhere and make this easier on myself. Okay. This is tab number. Okay. And so if I take let needed spaces equals, well, if I take tab number times columns per tab, and I subtract off the current column, outputter, is it? Okay. To subtract off the current column, I think I want that. So I want return string. I got one that does this, I think. Repeated value character count. Okay. Repeating space. Count is needed spaces. Okay.
We had water everywhere the other day. It just wouldn't stop.
What? It was running?
I went to flush it, and then it started to overflow. And I called my husband and said, it was just spewing.
Okay.
The water, I don't know where it was coming from. But we had more water.
All right. Let's see if we're doing good here. I think we got it.
He got it shut off, and I don't know.
Right.
It took us 12 towels to soak us all.
Of course not. All right. One SDR. Okay. Oh, we got a new line on the back of this thing.
We think that was probably the original toilet when
Yeah, we didn't end with a comma or semicolon, so it should have a new line.
this one's not supposed to.
Okay. So much for that excuse. Okay. Not equal to 125. Okay, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 6, 9. Oh, it's 11 spaces though. I think maybe 12 is a better number for our tab stop. Okay, because basically we got 369 plus the decimal point. We got 10 digits for a number, an arbitrary number. You can see why they did 15. Let's go back to that. Let's make it 15. So that's 5 more spaces. 1, 2, 3, 4, 5. Oops, that should not have a. That should have a leading space. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. its leading space 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Its trailing space. Okay, let's give that a try. What is that? Okay, that's 15. I think I can take off 3. Because this is 9, 10, 11. Yeah, let's take 3. And make this 12. So we're different from everybody. I don't know. Okay, let's see how that goes. Then we got some refactoring to do. Okay, so make tabs space in space 12 apart, 0, 11, etc. I think that should be 12, shouldn't it? I feel like I'm off by 1 though. 0 plus 12 is 12, plus 12 is 24. That seems okay. Okay. All right, so some cleanup. Well, we can get rid of this. Okay, so now we're printing them as we go. We're looking at the current column, so it's a little bit of work. This, let's make a constant up here. Columns per tab equals 12. Okay. Current column is that. Okay, tab. Okay, I'm reasonably happy there. Okay. We'll say it this way, 0, 12, 24. Okay. And I think we're done there. Support the tab function. Okay, well, let's commit this. Wait a minute. Something's not quite saved or something. That's better. Okay. Refactor. Head code. Extract constant. Okay, support the tab function. I guess that looks better like this, doesn't it? Okay. So let's remind ourselves. I think it just marks us, moves us to the specified column. The trick is tab. Well, let's find tab here. Wait a minute, where's my function? Oh, tab's not in here. Okay. Interesting. All right. So I think let's get a test for that. Print with commas. Let's do print with tab. All right, so if we print, well, if we print x followed by tab to 5, I expect, let's put a semicolon on the end and print another value, y. Okay, so print x, tab 5, print y. All right, what do we expect? Well, x 2, 3, 4, 5, y. Okay. What we're going to get is blow up because tab is not in our function list. And why this happens, let's get parser involved. Somewhere it has a list of functions. No, is it in here? No. Oh, apparently it doesn't work that way. Okay. Interpreter. Well, it fails there because we don't have a tab function. So let's define one. Sorry, let's go back where that failure is. 388. Okay. Let's capture some work here. I think better, well, we should get an error message for unknown function. Now, oh, maybe it's the Lexer that knows them. I thought somebody did. Yes. Okay. That makes me feel better. This is in our Lexer. We say tab's a legal function, and yet when you use it, we don't have it in the list of valid functions. So this is more of an internal error than an external error. So internal error because putting it on this list commits you to managing it in the interpreter. Okay. Which I should have done. All right. Well, tab is a value.function. It's a function number to string. Okay, and then how do you calculate it? Well, we're going to look at outputter. Do we don't have access to that? We do. Okay. Look at outputter.column is the current column. And if we take, oh no. Okay, let's make a separate standalone function then. Oh, we can't do that. Yeah, the challenge is I want to use the outputter to get the value of this thing, but I don't have access to it at construction time when I'm building this function. And if I make it an external function, it isn't going to work either. Okay, let's take a break. I have some thought of a way to get around it, but I don't know if it's going to work or not. So anyway, let's take a 3-minute break, come back at top of the hour and see what we can do. Okay, we're back. So,
You know what I mean? The stuff we know that don't work.
let's see. I think the options we have. Well, one is I can somehow try and make a function that returns a closure and call that. And maybe I can add that into the store later, like down here. I think if we put defer in, we could maybe add it because it would have initialized everything already. I can't have a local function though. So I'm going to have to have a function that takes an outputter. And
Mom? Yes, dear. Could you watch Martin for a minute, please? Yes, I'm coming.
yeah, so I could create a function that takes an outputter and returns a closure that is suitable for this thing. I don't know if I can call that directly. Let's try that. The other alternative I have is this value string maybe isn't the right value. It could there could be yet another type. I mean, another type of object that's like a tab object, and it's tabbed to a particular column, and when it gets evaluated, it turns into a string. Well, no, the printer stuff would have to know how to work it, I guess. So just like we called printable down here. Well, let's find it. Okay, so we would just have a new type that's like tab column or something, and it would take an int, like the argument of our tab, and it would say, oh, do all this stuff we already do. And that's a pretty low maintenance thing too. Okay, let's try the function thing just to see how that works, and then I don't know if it's gonna work. All right, but we'll find out. Okay, so my idea is I'm going to not put this entry in. Okay, and then down here I'm going to put what's it, globals? Globals sub tab equals, and then I'm going to make up this function build tab, and then what's it going to take? I don't think I think it takes an outputter. What does it produce? Well, it produces a function. And it's going to have to produce the function of the type up here. Okay. Well, it's a value.function. So let's go find that thing. Okay. It's array of values to value. Okay. Back to interpreter. Okay, so this goes to that. Okay. And now we're going to return a closure which takes arguments in. Okay. So this function let's return value of questions. Okay. Value has no accessible. Oh, string. Okay. Okay. So this is build tab of outputter. Okay. Cannot assign. Value dot function build tab of outputter. Okay. It's a little convoluted, right? So we're saying at construction time, when you build this object, we're going to give, most of these are just simple functions like this, just pure mathematical things. This function tab depends on the outputter. And because the outputter is not constructed when this is, I mean, this is constructed before the outputter conceptually anyway, then we can't reference it. Okay, so we have to work out a way to defer the reference. So what we're doing is we're saying, once you build the rest of it, let's now create this global tab function. Well, it's going to be a value.function because that's what that the store holds. And then the function is, well, it's the function returned by build tab, which is give me your arguments and I will give you a value back. Okay, so this function, it's almost like we could plug this in up here but it references outputter, so it's not going to work. We don't reference it yet because I'm just trying to make the blow up go away. Okay, so let's see what happens. I'm expecting a failing test with question marks in it. Okay, it looked good as it went by. Let's see what it says. Yeah. Okay, so you can see we took the tab and we just returned those 5 question marks. Okay, and this tried to take it into account, but didn't. It didn't match the spacing. Okay, but now I think we're ready to try it. Okay. Whoops, interpreter. So this tab, let's take this out. Okay, so what's the function here? Well, we're going to take outputter dot column. Okay, is the current column, and let's take the case. Okay, that's the current column. If we take, let's take value dot string. No, yeah, string repeating space, and then arguments of 0. Its first argument. Well, let's do that up here. Okay. Let desired column equal arguments sub 0 dot as float. Okay. we could probably change this a little bit and help ourselves. But anyway, okay. So arguments is float. Well, that's the desired column. Okay, and the column, the number of spaces we need, if we're in 0 and we want to be in 10, we got to have 10 spaces. So desired column minus current column. This is return. Okay. Find the current column. Okay. Okay, find the current column, find the desired columns, subtract the difference, and let's see if this passes. Good. Okay, now let's see if we can simplify. The thing I had in mind was we had that FN2N stuff. Okay. If you look at the signature of random, it's float to float. Okay, so I think we can do the same thing here. Init a value function. Let's take function numeric to numeric. Okay, and then this becomes float. Oh, actually, it just becomes single float to string. FN2S. Okay, if we get the types right. Okay, so FN2S. Oh, and now it's a single argument. Okay, let's just reference it as $0. is already afloat, so we don't need this. Okay, value.string. We don't need value.string anymore. Okay, it's definitely helping. Okay, what do we got left? Good. Okay, let's make sure it still works.
You want to work on your big bird and helmet puzzle again?
And you know, I'm going to add the word return here. That closure is the implicit return value, but I want to make it a little more explicit. I don't.
Oh, you want to do your bird and helmet puzzle?
Yeah, I think it helps to be a little explicit. That makes you go like, wait, what? Rather than the braces where it's just like, oh, it's executing these statements. Wait, you know. Okay, so I think that covers the simple case. Let's get one more case here. Where's tab? Print with tab. Okay. There's something else that can happen. Test print with tab to earlier column. Okay, so it'll be somewhat similar. Okay. Let's tab 0. Okay, so we've printed the X. So we're already past column 0. Well, let's print XYZ tab. Oh, I just want to make it more plausible. I don't want to do the border because it's sort of weird. I'll say tab 2 even, because that's where the Z is. Okay, and then the Y. Now, XYZ prints. I want a new line, and then I want 2 spaces and a Y. Okay, and because the tab's position is already been passed, Z is already there, we're going to say you should write a new line and force down to the next line. Okay. Some of these do that for, some basics do that for the comma stuff too. All right. So yeah, we get a negative number because the desired minus column is it's too far past. Desired minus column is negative. Okay, so if desired column is less than current column. Okay. If desired is less than, greater than current column. Okay. Greater than or equal, I guess 0 is okay, right? So if you're saying tab to column 7 and the next position you would write is 7, well, that's doable. Okay. If that's not the case, then we're going to return a string new line. Well, I guess it's new line plus this kind of thing. Okay. Desired column, current column is now 0, so we can just get rid of that. Okay. Okay, so we've covered that case now. So if they tab backwards, if they try and tab somewhere that would be backwards, we put a new line in it and then tab into the column they asked for. All right, let's commit. Add tab. If If next column to right to is less than the argument, insert a new line. Then tab to it. Okay. And then from the to-do perspective, support the tab function, yes. Okay. So I think that's everything we needed for print. All right. Error message for unknown function. That's kind of a can't happen situation. I mean, we let it happen, but I don't think it would normally. The fact that it blows up, we would do something about that. Okay. Ask do parser errors. I think we got this part, but we could do better. Interpreter format for arrays on GoSub. All right. Well, I'll tell you what. I think this is probably a good place to stop for today. I'll pick up next time and figure out like what statement or what thing will we look at. Maybe a little refactoring. Stop would be more on the control structure side. That might be interesting. This input thing is definitely a new kind of thing. That'll be a moderately dramatic change. So maybe that's my best statement candidate. But I kind of feel like I should do some other cleanup-y kind of things, kind of quality of life things. Okay, so maybe we'll do error handling more, but we'll pick up there. Next time is next week, Monday, 10 a.m. Eastern to 12:30 p.m. or 3 to 5:30 p.m. UTC. And thanks for joining me today, and I hope I catch you again. Have a good weekend. Bye-bye.